So we'll start covering the review sheet today. We'll cover about half of it today, half of it on Monday, and then your test will be Tuesday.
I forgot to tell you, thanks for the pizza.
Oh, you're welcome. As crazy as everything else was yesterday, I didn't think that those bologna or those ham sandwiches and was going to cut it, especially not after y'all, because that would have been no snack and then eat that at 1. That would not have been fun. All right, let's look at half of this here. Now the first ones, these here, I think y'all like these. Find the indicated root, our nth root of a. Well, if we look at number 1, what's our index? Our n value is 4. The number inside is 20,736. So we can come over here and say math. Go down to number 5, the x root, and say 4, and then 20,736. And we get 12. Now this one here is going to be one of the few that we do this with. We'll have the plus or minus. Because the rest of these, when we take the root, we'll just say whatever the number is. But on the first ones for these here, where we take the nth root of a, we'll add the plus or minus only on even roots. To where here, where we take the 9th root of 512, which I'm assuming is 3, 2, thank you, 2. We don't need the plus or minus because we're talking about an odd root. So there's just going to be 2. That's all we have to do for these here. No. And it's only going to be for these set here that we would need the plus or minus. Because later on, we're not really taking the roots anymore. We're going to be squaring or cubing to solve. So that's all we would need to do for this here. Any other questions on 1 through 4? We're good with 1 through 4. Evaluate the expression. So if we say evaluate, we're going to plug it in. We can plug these into the calculator and solve. So we can say 8 to the -2 divided by 3. 1/4. We could have done this in the graphing calculator. 8 to the -2 divided by 3. Now it does give us 0.25, which we can say math enter, which is also 1/4. So I'd take 0.25 or 1/4 for that one there. Any other questions on 5 through 8? Or do we like 5 through 8? For the most part, we like 5 through 8. Okay, which other one? Number 7, 1/9 to the 3/2. So here we can say parentheses alpha y equals enter 1/9 to the 3/2. Now we could type it in as a fraction or say 3 divided by 2. Which is 1/27. And that's it. That's all we have to do for this here. So 5 through 8, we can just type these in the calculator and we're good. Any other questions on 5 through 8? Questions on 9, 10, or 11, or 12? Because what can we do for all these here? Type them in. So we can say 8/16 to the 1/9. 8/16 to the 1 divided by 9. 2.1063. 2.1063. That's it. Any other questions on these here? Questions on 13 through 16. And 16's answer is wrong in the answer key. So when we look at this one here, if we type it into the calculator will give us an ugly decimal. But if we use our properties of exponents, one of them, if we multiply like bases, we add the exponents, which here is not too bad if it decides not to scroll. So we would add the exponents together, which would be, if it would stop doing that, 1/2 plus -3/2, and we have this to the -1/4. Now what is 1/2 plus -3/2? It would be -1. Because we would have 1 minus 3, which is -2. -2 divided by 2 is -1. Now, powers of powers multiply. Well, 1 times -1 times -1/4. 1/4. Now, for some, stopping here would be one of the answers. But if we look at 4, can I rewrite 4 as a number to a power? Oh, yes, it would be 2 squared. 2 squared, 4 is a perfect square. 2 squared. Now the reason I say this is because here, again, powers of powers multiply. So 2 times 1/4 is? So really we could simplify this all the way down to 2 to the 1/2. But the answer key had 4 to the 1/8, which isn't right. That's not the correct answer. Now we could have done it another way and applied the -1/4 first and then added the exponents, and we would actually get to the exact same spot. For some reason, I realized what I did is, for some reason when I added those together, I left it as 1/2, -1/2, not -1, which would have given us 1/8. So it's 1/2 times 1/4 is 1/8. So this should have been 2 to the 1/2. Now, with most of these here, except for 15, we're going to be left with a number to a power. Because number 13, 6 to the 3rd to the 1/4, powers of powers multiply. So what is 3 times 1/4? So the answer is 6 to the 3/4. That's all we had to do. We just had to multiply those powers together. Now for 14, look at all this here. Try again. There we go. Before we do any simplifying, will 9 over 12 reduce? Yeah, it reduces to what? 3 over 4. Now, we can apply the negative 3/4 to the numerator and denominator. Now, we can't leave exponents negative. So to make it positive, we either move it from the numerator to the denominator or denominator to the numerator. So our 3 to the negative 3/4, to make the 3/4 positive, we move it to the bottom of the fraction. Well, to make 4 to the negative 3/4 positive, we move it from the denominator to the numerator. And we get this here, and this is where the answer left off. And that's where we're going to leave it. Now, some won't leave it here because we can't really leave a fractional exponent in the bottom of a fraction, because what we're doing is leaving a radical in the bottom of a fraction. So to simplify that, we would need to multiply top and bottom by 3 to the 1/4 to get that 1/4 exponent to become 1, so we don't have a fraction. But we'll leave it here because we're not going to have one like this on the test. Now what's nice is this one here, you could actually type this into the calculator and get the answer, which is, I believe, 4. Now, there's several different ways we can look at this. One of them is dealing with the fact that all 3 of these do have the same exponent, yes? Because the numerator has 2/3 on both numbers. The denominator has 2/3. Now, over here, what did we do with the negative 3/4? We applied it to all the numerators and all the denominators, yes? I can go the other direction. I can pull it away. Now, part of the reason I'm doing that is if I look at the values, we have 2, 16, and 4, yes? Well, the numerators and denominators simplify, because will 16 over 4 simplify? Well, yes. And when we look at something like this here and see, okay, especially the 4 and 16 do have like terms, they can simplify. I can simplify numerator and denominator, especially if those powers aren't there. Pull them all out, because since they all have the same power, we can have the 2/3 out here, but that leaves us with 2 times 16 over 4. Well, 16 divided by 4 is 4. Well, 4 times 2 is what? 8 to the 2/3. Now we need to simplify this here if we can, because we have the 3 on bottom, yes? The 3 on the bottom of a fractional exponent is talking about a cubed root. So it'd be nice if 8 was a number times itself 3 times 2, because 8 is 2 to the 3rd. Now if we multiplied those exponents, 2 times 3 is 6. 6 divided by 3 is 2 squared is 4. So a lot of this is using the properties of exponents to get to the answer. Now, not remembering all of these properties is not uncommon, especially if you're not used to using them. So using examples sometimes helps, especially if we have numbers to get there. Here, this worked out. We could have typed the whole thing in and got 4. If y'all end up taking the ACT or want to take it, because you're not mandatory, we're not making you take it again after this year. But especially on the answer key, if all of them are numbers, plug the darn thing in. But if we do have fractional exponents, try to work to it, which is part of the nice thing. If you ever take a math test that has answer choices, you can work to the answer. But Any other questions on these here, 13 through 16? (17 through 20). Yes. 20. Because I think the rest of them actually work out nicely in a calculator. Because square root of 2 times square root of 72 is 4, or not 4, 12. Now, the reason I say that is if we look at this here, 72 times 2, because since the radicals are the same, we can multiply what's inside. Well, our 2 times 2 is 4. 2 times 7 is 14. 144 is 12 squared, so we get to 12. Now, what we're doing there is trying to reduce the radicals. Here, well, we have the 4th root of 8 times the 4th root of 8. 8 times 8 is 64. Now we need to see if we can take the 4th root of 64, which unfortunately doesn't work. Now if we looked at the factor tree, well, 2 works, 2 and 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4 is, well, 2 and 2. Apparently I'm going to write over the top. Well, how many 2's do we have here? 6. So 64 is 2 to the 6th. Now there's different ways we can go about simplifying from here. One of them is we can bring out groups of 6, or we can rewrite this as a fractional exponent. Now if I rewrote this as a fractional exponent, the root goes on bottom, and the power goes on top. So we'll get something like this here, 2 to the 6/4. Now the 6 is bigger than the 4, yes? So that means that there's whole groups that come out. Because we can pull one group of 4 out and say that this is the same as 2 in the 1 and 2/4, yes? Because we took one group of 4 out, so we're left with 2/4. Here, can we pull another group of 4 out? Well, no, because the numerator is now smaller than the denominator, yes? Oh, wait a minute. What's 2/4 the same as? So we're saying that we have 1 and 1/2. Now for us, the 1 for the 2 is going to come out of that radical. Now the fraction tells me kind of what the radical is left over. The 2 is our root. Since it's 2, we don't have to write it, square roots. And how many 2's are left inside? 1. This actually works out to be 2 times square root of 2, which is the same as saying 2 times the 4th root of 4. Because 2/4 is going to be the 4th root of 4. Questions on this here? And manipulating these radicals is really all this is looking at. There won't be something as complicated as 20 on the test. Now, if we wanted to look at 18, really, what we're doing is dividing those two and seeing if we can take the 5th root of it. I'm not the only one that heard something.
No, I heard it too.
No idea where that came from. But this one here, most likely, we can plug into the calculator as well as 19. Any other questions on these here? We'll finish up with these. Which one of these do we want to look at? (22). Now to simplify this, what we do is we multiply by the irrational conjugate. The conjugate's really saying that we take this, and whatever the sign is, we flip it. Since the sign is negative, we change it to positive. And we have square root of 3 and square root of 5, because the main goal is to get all the radicals out of the denominators. So in the numerator, we're going to take square root of 6 times square root of 3, which would be square root of 18, plus square root of 6 times 5 is going to be square root of 30. The denominator, square root of 3 times the square root of 3, actually works out to be just 3, because it's the square root of 9. 3 times 3 is 9. And what is the square root of 9? 3. Then we'll do square root of 3 times positive 5, square root of 5, which would be square root of 15. Negative 5, square root of 5 times square root of 3 is going to be negative square root of 15. Negative square root of 5 times square root of 5 is going to be negative 5. Because square root of 5 times square root of 5 is the square root of 25. Square root of 25 is just 5. Somehow I knew that was going to happen. Now, the denominator, square root of 15, negative square root of 15 are gone. So we're left with 3 minus 5, which is negative 2. Now, it's always good to check the numerator to make sure there's no perfect squares. Square root of 18 is 9 times 2. Whole square root of 9 is 3 square root of 2. Now, it's good to check 30 to see if there's any perfect squares. Do you all know what the perfect square number is? 4. I mean, besides 1. We don't include 1. Is 30 divisible by 4? Well, no. The next number after 4, because 4 doesn't work, would be 3 squared, which is 9. Is 30 divisible by 9? No. So that doesn't work. The number after 9 would be 16, which is 4 squared. 30 is definitely not divisible by 16. And you all know the number after it? Because that was 4 squared. What's the next one? 5 squared, which is 25. Well, 30 is definitely not divisible by 25. So we get this here. Another way we could say this is moving the negative up top is negative 3 square root of 2 minus the square root of 30 over 2. Graphing calculator definitely won't do this, but we can look at this one here. Second square root 6 over second square root 3 minus second square root 5. Is that the same thing we got? I mean, they flipped the square root of 30 and 3 square root of 2, but that's the exact same answer. So the TI-30XX, TI-30XS will do these here. Any of these here. Yes, but they moved the negative up to the numerator because the one that we started with the negative 2 on bottom had the square root of 30 and 3 square root of 2 as both being positive, yes? Yes. Now, most of the time, just standard operations, we don't like leaving negatives in the bottom of the fraction if we can avoid it, so they'll move it and apply it to the numerator. Because essentially, what we did to go from here to here is that we factored a negative 1 out of the bottom. So we're saying negative 1 times, I'll flip them around, square root of 30 plus 3 square root of 2 over 2. And then multiplied it back through the numerator to get there. Any other questions on this here? Now we'll stop here.